Anatomy of algebraic expressions. Make sure that you are taking notes if you're watching this from home. We're going to be learning about the parts of an algebraic expression, and when I'm talking anatomy, that is basically the components of a math equation. So our algebra is made up of body parts, just like our own body is. So if you can think of parts, maybe your hand, what about some bones? Your femur, your patella, your ribs, your phalanges. We have all types and kinds of anatomy of the human body, and algebra or math is just the same. And this is going to be critically important for us to understand as we advance through algebra. So let's look at the parts of an expression here. First of all, we have terms. We also have, and I'll go over each of these individually, we have variables, coefficients, and constants. Jot those down, and then we're going to take a closer look at each one of these so that we can understand the different parts of algebra. And again, think of them just like parts of anatomy for any kind of living thing. So this is an algebraic expression right here. Each one of these bones is going to represent a piece of our anatomy. To start with, I have the number 3. We're very familiar with just numbers in our expressions. We call this a constant. That means that it never changes. A constant is a number that does not change. It is constantly there. The sun constantly shines. This number will be very reliable. It will never change its value. So regular old numbers we are going to call constants. Now we have something new. We've been waiting a long time to have variables. That's what this is. An x is a variable. It's basically just a symbol that represents something we don't know. So a variable can change. We can put different numbers in for a variable and we don't know what it means. Let's look at the next piece here. Finally, I have combined a number and a variable. This combination is called a term. When I have these two together, this is called a term. A term is just a number, variable, or combination of both that are separated by a plus, minus, multiplication, or division sign. And what that means is that essentially, I think of a term as a word in a sentence. So, and terms are used in language arts, aren't they? We have terms that define things. These are terms. This is a term, 5y, in my algebraic expression. 3 is a term. X is a term. Each one of these is a term. No, you know that in a sentence, words, how do we know what a word is? Well, one word ends and one word begins. There's a space between it. To tell where one term ends and another term begins, we look for operation signs. There's an operation like a plus, a minus, multiplication, division between them. So again, our terms are just words in a sentence, words in an algebraic expression. 3 is a term, x is a term, 5y is a term. Let's look at our very last thing here, the coefficient. So I started to talk about this in the last, and I apologize for that, but now we're on to this where I have a number or a constant in front of a variable. Whenever I have this combination, this number that's in front of my variable is called the coefficient. So think of co, and sometimes we need to break these words apart as company. Co is company. So the number and the variable are company when we have them together. So let's go ahead and analyze these bones and see if you were listening. I need a pen here. Give me just a moment. So the constants, remember that a constant never changes, and I have one constant. When I'm looking at the constants, I'm going to look at the operation sign as well. So this minus sign, I'm going to actually think of it as a negative. So my constant here is a -5. Terms, remember that terms are like words in a sentence, and we know that where one word stops and one word ends, we understand that because they're spaces, but when we're looking at an expression, what we have in between them is an operation sign. So in this case, I have a plus and a minus. That tells me that this is a term, so I have 11t. My u, the variable u, is actually a term, and then my -5 is a term. Okay, variables. What are my variables in this? Variables, again, represent something that we don't know, and they're just symbols. I have two variables. I have a t and I have a u. Finally, what are my coefficients? The coefficients, like company. When we have company, we're together with somebody, right? In this case, my only coefficient is 11, but there's actually another one here that I can't see that's invisible. So I'm going to write down my 11. Here's the tricky one. How many u's do I have right here? You might be asking yourself, what's she talking about? Well, there is an invisible 1 in front of this u, and I want you to write that in to your expression. There's an invisible 1 always there. The reason we don't write it is we assume if there's a u here, there is one u. So my coefficients, I have an 11 and the number 1. Okay, let's move on. Oh, and backing up, didn't know my own slideshow. So when a variable is alone, its coefficient is 1, and that's what I was just talking about. So it's like there's an invisible 1 in front of this u. So now let's move on to this next one. Pause the video, see if you can do it on your own. Let's go ahead, look. Let's see, do we have any constants? Again, a constant is a number that never changes. It's constantly the same, and I have just one. That's my 9. Terms are separated by operation signs. It looks like I have 3 terms. We have 4x, 3y, and a 9. Variables. It appears we have 2 variables, an x and a y. Again, they're just symbols that represent something we don't know, an unknown number. Finally, coefficients. Co is company again. What's in front of my variables? I have a 4. Whoa. Writing with a mouse is a lot more difficult than it looks. I have a 4 and a 3. Okay, so let's go ahead and move on. So we can solve algebraic expressions. This is called substitution. Suddenly, I know what this, remember that this is a variable, k is. And right here it tells me that k is actually 5. So all I will do is substitute in the value of 5 for k, because now I know it's no longer unknown. I know what k means. So we would just say 5 plus 10, and we can just solve, equals 15. Okay, let's try. I believe I have one more here. Whoops. Did I skip? Nope. Okay, one more. So here it's telling me that the value of n is 3. I am going to substitute. So if I am gone from school, I will have a substitute who takes my place. This 3 is substituting in for the variable n. Here is something that's very important, and I don't want you to forget this, especially as you move to 7th grade, 8th grade. This is going to follow you. When I have a term that has a constant and a variable together, in other words, I have a number and a variable together. These two are multiplying. This is the same as saying 4 times n. So I am going to rewrite this like this: 4 times 3. Plus 6. So again, if you didn't catch that, if I have a 4n or a 4x or a 4w, whatever it is 4 times whatever that variable is. That's super important that we remember that. We'll follow our order of operations to solve this. 4 times 3 is 12, plus 6, and hopefully you said that it's 18.